Hello, I'm Mustafa. I'm an assistant professor in the mechanical engineering department at New Mexico Tech. So the course that I'm going to teach for the Master of Science teaching program is Introduction to Unmanned Aerial Systems, or UAS. So in the first lecture, I usually give students an overview about my research area and also the course that we are going to talk about that. So this presentation is about biomimetics and bio-inspired autonomous aerial and aquatic vehicles. So I have a lab at New Mexico Tech, which is called Autonomous Flight and Aquatic System Laboratory, that I would like to show you an overall view of the stuff that we are doing at New Mexico Tech, and then proceed with the materials for the course, that how we can actually design an unmanned aerial system. So we know that the drones, they have different classification, different types. They generally classify from UAVs with the wingspan of the 61 meter and a weight of the 15,000 kilogram, to the smart dust, which they are in the dust particle. They are not visible, and they can fly like drones, but they are in very, very small sizes, that they can do whatever a drone can do as a mission. So in this spectrum, we have UAV, unmanned aerial vehicle, we have micro UAV, and we have three classes of micro drones, including MAV, NAV, and PAV. So in the next lecture, I'm going to discuss more about the classification of the drones and also the different configurations. So these types of the drones, from UAV to micro UAV, has a big range. So UAV, generally, they are a bigger drone that they need a runway to fly. Then and the micro UAV are similar to the UAV, but smaller size. They are usually hand launched, so you can hand launch them. And we have three classes of micro drones that we can have different configuration, including the fixed wing, flapping wing drones, which they are inspired from the birds, and multi-rotors like quadcopters and hexacopters, that we will see them in our daily life. We also have bio drones that we will discuss this actually in the next lecture, that why we need to use a dead body of animal as a platform of the drones, or for example, what benefits you can get from this, and what are the challenges of the drones once you have more smaller size. So drones have 200 applications. So depend on the flight zone and depend on the mission or environment, we can have a different categories of the drones. So for example, if we are going to fly our drones under the water or over the surface of the water or on the ground or in the air or space, so the type and the design process of these drones will be different. So the classification can be happen because of the flight zone in the indoor or outer space, based on the mission. It's a military or civil application or emergency application, or based on the environment that they are flying. So in the future, I'll discuss about the opportunities that we can have with the implementation of the drones in our daily life, and how we can use drones for different types of applications or missions. So this is the main topic area that we are actually working at the mechanical engineering department at New Mexico Tech. So one of the applications of the drones is for planetary exploration. It means that we want to have drones that can fly in other planets or other solar bodies. So we know that once you are designing a drone, the aerodynamics, which is actually the forces that can be provided for this type of aircraft in order to fly, it depends on the flight characteristics and also the atmospheric characteristics of the planet that we are going to fly our drone. So for example, we can design a drone which can fly on Mars. We can design a drone which can fly in the Titan, and it can perform a dynamic soaring, land over the liquid methane on Titan, and harvest liquid methane as the sources of its energy. So we know that NASA is so interested in designing some drones that can fly in other solar bodies. So what we are thinking here at New Mexico Tech is that Titan is the moon of the Saturn, and we know it has a liquid methane, and we know that the liquid methane can be as a sources of energy. So what we are thinking about, we want to design a drone which can fly on Titan. It can land over the liquid methane and harvest this liquid methane as the sources of its energy. Also, we know that we have the Venus, which is closest, one of the closest planet or solar bodies to the Earth. And we know that Venus has very harsh conditions. So it means the temperature is so high, high pressure, and acidic environment. So all the mission that NASA has designed or other space agencies that they have sent some landers or some rovers to the Venus, actually they couldn't tolerate long in that planet because of the harsh condition, because all the sensors actually cannot work after 2 hours because of this harsh condition of high pressure, high temperature, and acidic environment that we have on the Venus. So one of the projects that we are working at New Mexico Tech in the mechanical engineering department, we are designing a drone which is able to fly in different elevation of the Venus and harvest energy from this temperature difference in different altitudes, and somehow can perform different types of mission in the planet. So the other topics that we are looking at is energy harvesting from available sources in the solar bodies for the drones. So for example, imagine that recently, most of the drones that we are using, they are using solar panels, or they are using, for example, batteries or fossil fuels. So what we are thinking here is some novel mechanisms to provide energy for the drones, which we don't have the same control as we have on Earth for other planets, in order to perform different types of mission. So this is one of the applications of the drones, that they can fly in other planets. So the another topic that actually is somehow related to these robotic systems is, again, space explorations. So a space exploration can be performed by different mechanisms. So they can be performed by lander, by rover, by probes, by satellites, by telescopes. So there are different mechanisms that space agencies, they are using drones or actually the other autonomous systems for planetary exploration. So the thing that we are looking at here is the new generations of the flying concepts or ground-based concepts that can be applied on Mars or Moon or other planets for exploration. So we know that from 1976, NASA is looking to design some aircraft or some fixing drones that they can fly on Mars. But the thing that here we are looking at, why we need drones to fly in other planets, why we don't use the rovers. So we know we are familiar with the Opportunity and the Curiosity rovers that NASA has sent it to the Mars for exploration. But we know the Opportunity rover, it was working for 14 years and it stopped because dust covered solar panel. And we know the Curiosity rover is still working, but it's limited to a small range around 5 to 10 miles, so they cannot go further. So what is the solution if we want to further investigate those planets? So the application that we can have here is that the drones can be applied to be deployed on actually different planets like Mars for exploration. But they have some challenges and some risks with the deployment. How with the data actually returning, it's a 14 minutes delay. If you want to send some instruction to a drone which is flying on Mars, and also to receive data also from that. So it's a long time. So therefore, if something happened here, we are going to easily lose control on our drone. So what is the solution here? And so due to this, we are working on some new concepts, which they have a combination of the ground-based rovers and also the flying concepts or flying objects that they can be combined and they can be used for planetary explorations like Mars or Moon. So here I'm going to show you some flying or moving concepts that they are harvesting energy from the available winds on Mars. We know that there are some winter storm on Mars. There are a pattern of the wind on Mars, and Mars has very, very low dense air. So it doesn't actually have a low dense atmosphere, which is mainly consists of the carbon dioxide. So what we can do here to perform a well-defined mission for this planet, for the red planet. So if we look at the nature, usually we can get inspiration. We know that any species that we see on the nature, they have different characteristics and they have been adapted to the nature based on, through the evolution. So one of this, they can be animals, they can be insects, they can be birds, or they can be some plants. So let's look at the dandelion shape and see what idea we can get from dandelion in order to actually design some robotic or flying objects that based on this dandelion in order to perform different types of mission or harvest available winds on Mars to design a new generation of the flying objects on the red planet. So if you look at the dandelion, we will see that they are flying like these concepts. So dandelion, they are wind driven, so they have a central part, and there are the dandelion seeds that they can be separated by the wind, as you can see here, and somehow how we can design some robotic or flying objects that they can fly like this dandelion. So the concept that we are looking at is designing a rolling rover, like this, which can roll in the harsh and the rocky surface area of the Mars, and it has some dandelion shaped flying objects that they can carry different types of the sensors, as you can see here. And in the case of the high-speed winds, so this can be launched into the air of to the atmosphere of the Mars, and they can be the wind driven. So this is one of the concept, flying concept, and the ground-based concept which can be inspired from the nature. So in this course, I also would like a little bit show you some background that how we look at the nature, we can get inspiration in order to design some optimized aerospace systems, aircraft, drones, or other objects. So the other concept that we are looking at is actually this type of spider here. As I said, the Mars has very rocky surface area. So so what we can do here is that if we design some concept that can roll over this harsh condition and it can jump. So let's see what species we have in nature. As you can see, we have this the spider. So I'm going to show you this video. So if you look at this spider, you will see that this spider rolls. So how this acts, actually this spider is really interesting, that can actually move very fast in a desert, in a slope. And the main reason that they are showing this behavior, they are rolling and they are jumping, is that they want to actually escape from the predator. And also they can save energy, because with this type of mission, they are saving energy. So we are thinking about this concept to design some robotic systems that they can move over the Mars, and in the sense of, I mean, facing some rocks or some obstacles so they can jump. So my undergrad students, they have made actually a concept of this rolling rover. So now let's look at the other species or plants that we have on Earth. So the another concept for the Mars exploration as a robotic system that can be applied are some rolling robots that they can harvest energy from the wind. So if you look at the nature, specifically on Texas, we can see the tumbleweeds. So the tumbleweeds are some plants and dried plants that they can harvest energy from the winds, and they can move actually based on the energy that you are receiving from the winds. So if we consider a circle, these tumbleweeds are actually harvesting energy and they can roll. So what we are thinking about, and NASA has done this in 2004, is designing some micro rovers that they are like tumbleweed, and they can roll and they can harvest energy from the wind, and actually they are the wind driven, and they can move long distances over the Mars. They can communicate with each other, and you can do for the monitoring of the red planet. So I'm going to run this, that you can see how the tumbleweeds are moving, and they can harvest the wind on the Mars. So this is a way that they move, and we can get some inspiration to design a new generations of the rovers or flying object that they are just rely on the wind. So the other concept that we are looking at is the insect, is the locust. So we know the locusts, they are jumping. So if we get to the moon, I mean the lunar environment, we will see that there is no any atmosphere there. So the drones, they cannot fly, because I want to show to you what are the physics behind to any flying object is the air. So there should be some concept that can easily actually fly once you have the atmosphere. But on the moon, we don't have any atmosphere. So what is the solution and what we can do here? So if you look at this planet, so we cannot fly. So, but there is always some challenges for every object, like a rover or some robots, that they are moving over the surface of the Mars, because since there is no any air, so any motion, it creates a dust, that this dust can get to the sensors, and somehow it can create some problems for our concept. So looking at the nature, we find this species, the locusts, that they are showing a very, very interesting behavior. So they usually can fly and they can jump. So what we are looking at, we want to design some rovers with the jumping capabilities that can perform different missions on the lunar surface. So these are another projects that, I mean, we can just look at the nature for designing some robots or flying objects for planetary exploration. In other future lectures, I will give you a presentation about the space drone specifically, and how if you want to design a drone which can fly in other planets and solar bodies, how we can perform the design process, and what type of material we can use, how we're going to control them, how we are going to send an aircraft or a drone to the other planet if we don't have any control on that. So these are the other materials that I will give you in future, some lectures about the fundamental behind this. The next topic, which is so interesting and is again related to designing space actually robots or a space drone or the rover, is that how we can investigate that, for example, our design can work in those planets. So if we compare the Mars with the Earth, we know that the density of the Mars is 0.1 kilogram per meter cube. And the density is decreasing once you are moving from the surface to the higher elevations. And we know that the density of the air or the atmosphere on Earth in the sea level is 1.225. So if you compare these two together, is around 120 times the density of the air is denser than the density of the atmosphere on Mars. So if we design a drone which is flying on Earth, it's not going to be similar with the drone which is flying on Mars, because the atmospheric conditions are different. So what is the solution here and what you can do here? So one of the projects that we are looking at, we want to simulate the Martian environment in a box or other planets. So if we create a box, we know that, so the characteristics that we need to consider is the density, the type of the gases, is temperature, is the pressure, is the sources of the radiation and the type of the radiation that you are receiving, and the type of the dust, or any particle that we have in the atmosphere of the Martian environment. So one of the projects that we are looking at, just to give you an overall view about this robot that you can see here, we know that the Opportunity rover NASA sent it to the Mars in 2004. It was supposed to work for 4 months, but it worked for 14 years, and it was a fantastic mission that this rover could carry out. But unfortunately, because of the dust storm there, the dust covered the solar panel of the rover, and eventually this rover stopped there because it couldn't charge its batteries. So here, one of the projects that we have done, we have actually made a rover which has a camera here. There is a camera here which is taking picture from the solar panel. There is an Arduino board and the Raspberry Pi, which works as the brain of these robots. So this Raspberry Pi, which we can have a Linux system or a Windows system on that, is like a small computer. It can perform the image processing. So this camera is taking picture from this solar panel, and then it runs the image processing. And in case of the dust, so it will send some instructions to the wiper or any other mechanism to clean out the solar panel. So in the experiments that my students did, we had the Martian dust and we have the lunar dust. We saw that how the efficiency or generated power or voltage or current is changing based on the amount of the dust which is covering the solar panel. You can see once the solar panels are covered by the dust, they are going to lose their efficiency. So then another project which is related to drone, this is the main reason that I am discussing here this project, is that if you have a drone which is flying in the Mars or Venus or Moon, how we can test it in the Earth. So there are different ways to test an aerial object which is supposed to fly on Mars or in actually other solar bodies, how we can test it. So one of the approaches that we have seen specifically for drones, for aircraft that they are designed to fly on Mars, is that if you go to the altitudes of 35 kilometers from the sea level, you will get the same condition of the Mars. You will get the same density, maybe the same gravity, which is the 30% of the gravity of the Earth. So in this way, we can actually send the aircrafts or the drones or unmanned systems with the hot air balloons to those altitudes and deploy them into the air and see that how they perform. So this is one of the methods that has been proposed by researchers. So one of the projects that here we are looking at, we want to make some stands and make a box, simulate the type of the gases, the Martian regolith, which is a Martian dust, the dry ice to create the type of the gases, and then make a station that we can actually attach different types of the systems in order to see that how they are acting in those environments. So this is a simulated Martian environment that we are creating the box, and we want to see, for example, how a flapping wing drone is acting in this environment. And we can measure the forces and see, or do some simulation to actually simulate the fly of these autonomous systems on Martian environment. So these are the space-related projects that we are doing at New Mexico Tech. In case that if you had any question regarding this, you can directly send me an email, and I would be happy to go over this material if it interests you with more details. So as I said, looking at nature, it shows us some benefits, and actually it can provide us some benefits, and it can help us with designing some novel system that they have higher efficiency than other available systems. So most of you have seen the formation flight of the aircraft. So the aircraft that they are flying in the V formation, or in the Echelon flight, or different configuration, they are flying together. So what benefits we are getting from this? So if you look at the nature, there are some species like birds, migratory birds, small birds, fish, or the other animals that they are working together, also wolf. So if you look at the migratory birds, we usually see them that they have a formation flight. I mean, they are flying in a V formation or Echelon formation, sometimes in U formation. So what is the main reason behind this? So we know that, I will give you more details of these materials, I mean, in the future, that why actually this happens and how we can get benefits from this once you want to design an aircraft or once you want to design a drone. So usually there are different reasons that these agents or these animals or birds, they are showing this type of behaviors. So one of the concepts that we are seeing is that they want to save energy. So we have seen the natures that the birds, once they are flying in a V formation, so like this. So this is a one side of the V. So usually some type of vortices, they are generated, which is called upwash and downwash effects. That I'm going to show you this material in future, which helps the birds which they are in the middle to consume less energy. And the birds that they are in the lead positions or they are in the tail position, they are consuming more energy. So we have seen that, I mean, in the literature, in some experiments that they have, have been carried out by other researchers from 200 years ago or 100 years ago. So the birds are taking advantage. So they can save energy up to 71% once they are flying in a V formation. So therefore, we can explain this. The main reason of the flying in a V formation or Echelon formation like this, the main reason is that they are taking advantage. They have a drag reduction, which means that they have less resistance to the air. They can save more energy. They can fly further. They can go faster, so they can get benefits. So, but sometimes, I mean, if you just have one bird which is flying, so we will see some challenges here. So if they don't switch their position, so the front birds is usually consuming more and more energy than the others. So what would happen here? These birds actually they are switching their positions with the birds which they are in the mid positions or mid locations. So therefore, the birds that they have consumed less energy and they have actually more energy, they can take the lead and somehow have a load balancing. It means that they can distribute their energy between themselves, work together to achieve a goal. So this can be seen in the Canada geese, in northern bald ibises, in pelicans, in different species. So this is a video that I have recorded from the Bosque del Apache National Wildlife Refuge, which is near Socorro. And every year we have this migratory bird, which is flying from Canada or different regions to this national park. So we'll see that how they're repositioning and how they are flying together in order to save energy. So If you look at here, I mean, this is a short video, shows you that they make a V formation, then they can change the formation to the acorn flight or a line flight, and how one of the birds become as the leader of the other bird. So the another thing is, is smaller birds or insects like the bees. So why we see these type of behaviors? Why, for example, they fly by thousands of birds, small birds or insects, they are flying together. So here, the main concept is not, about aerodynamics or, for example, saving energy. The main reason is escaping from predators. So imagine that if we have, let's say, a birds coming here, a predator birds, so they can actually change this formation or the shape of this cluster is called swarming in order to escape from the predator or scare the predator. Or another reason can be for finding the food. So for example, if any of these birds find a food, so the otter can follow them in order to actually lead the rest of the birds to the sources of the food. So the same can be seen under the water. So we have the school of the fish or a schooling. So this is actually a multi-agent system or organisms in order to actually take advantage from this type of behavior to escape from a predator or to distract the predator to escape. So these are actually calling the flocking, swarming, and schooling, and also we have in some land animals like the wolf, which is called hare. So these are the multi-agent systems. So due to this, we as an aerospace engineer or mechanical engineer, we are looking at this phenomena to see how we can take advantage to apply this on the design of the aircraft or on the design of the drones. So this is another experiments that we have done. There are different methods to run different aerodynamic analysis. So what here we are thinking about that and we wanted to do is that how we can simulate this. I mean, it's so complicated if you want to fly a bunch of drones together to see actually what would happen. So due to this, we as an engineer, we usually look at in other opportunities that are available to run different types of simulations. So here there is a software which I'm going to show you the whole software that you will be able to design a full airplane that run different types of aerodynamic analysis, which I am going to talk about the fundamental of that as well, so you will know that how we do this calculation from where this analysis can be performed. So this is some simulation that we have done, the same software I'm going to teach you in this class. There are a bunch of the wings that are flying in V formation, and here we are showing you that how these wings, the number of the wings that we are simulating, it can reduce the drag or enhance the efficiency of the system. So these are actually 5 wings, as we can see here. So this is from the top view of the V formation, and here the distance from the wingtip of this wing to this thing is so important. So there's a specified distance which is called wingtip spacing, which can gives us the highest performance for our flocking formation or the formation of the aircraft. So I'm not going to discuss about the fundamental of this. It just shows you how with inspiration from the nature, we can get inspiration or an idea for the flying object that we will have. So actually the material that I'm talking here, just for your information, I'm not going to ask you this material. So this is some research side of the course that I am going to teach for this class. There are also different experiment studies that we can carry out. So you saw the V formation. There was some analytical approach or some computational approach that we are using different types of the softwares. And another way is actually applying the experimental studies. So we can do these experiments actually in the real world. We can get the drones and fly them together, or we can actually simulate them and put them in a wind tunnel or water channel to run different types of analysis. So, and this is one of the projects for the other course that I was teaching in mechanical engineering department. For the thermofluid systems that students actually did this work is they 3D printed the formation of the wing, as you can see here. We put them in a water channel in a laminar flow with just flow visualization. We saw that how the flow is acting once they are passing through this V formation. So this is a top view of this experiment. So you'll see that we have the wings here, and the flow is actually passing through this, and this orange color actually particles that you will see is for the visualization of the velocity vectors of the flow of the water for a simulation. As I said, there are different ways we can run this type of analysis in wind tunnel. We can do in the water channel. There are different ways that actually we can carry out different experiments in the laboratories. So the another concept again for this formation flight, this is just another concept we can get inspiration from the nature. So there are animals that are working together in air in order to take advantage from each other, so or different species. So for example, if you look at the plants and the insects like the bees and the flowers, so we know that the bees are usually land on the top of the flowers to actually to feed. So what advantage both they can get? So if you look at this picture, that we can see this bee is taking advantage from the flower, and also flower can somehow take advantage from the bees, because the bees, they are scattering the flower seeds, and it helps them to reproduce themselves. So, or for example, if you look at the ant colonies, that how they can attach together to create a bridge, right? So what idea we can get from here? So let's first talk about this concept of the airplane that actually is one of the projects that I have done 7 years ago to see what we can get inspiration from this, and what idea we can get from this, and what is this project, and how we can design this concept. So if we look at, the applications of the drones, so some of their applications are for military application, or for surveillance, or for example, for inspection, patrolling. There are plenty of applications that we have for the drones. So if we look at the drones, specifically, if we just use one drone, we just have one chance to perform our mission. If something happened for this drone, for sure we are going to lose our mission. I mean, we cannot proceed our mission. So this is a high risk. So drones depend on their sizes. This is something that I'm going to talk about that with more details. Drones have different sizes, right? So for example, some of them are the bigger, some of them are smaller, like the aircrafts. I mean, a passenger aircraft, like Boeing 747, or for example, the Cessna aircraft, right? So they have different sizes. So what we understand from here is that if we have a drone which has a smaller size, so it means that we have a smaller surface area, so they cannot fly in the higher elevation because the wing span is small and the surface area is small. You don't get enough lift, and you will be run off the charge soon. And if you don't land your airplane or your drone, so they will crash. So what here we can do is actually how we can take benefits from the smaller drone or the larger drone. So once you're increasing the wingspan of our aircraft, so it means that we can get the higher efficiency systems, higher efficiency flight. So what we are thinking here is that, okay, so if we have just one drone, we have one chance to perform a mission. So is this drone should be a small drone or the big drone? All right, it depends on the mission. So this concept that you can see here is a one drone which is flying as a one UAV. It's an unmanned aerial vehicle. It can fly for the long distances, and in three conditions, it can separate it to 5 smaller drones. So why this happens? So for example, imagine that a rocket is locked on this drone and is going to destroy our drone. So if the rocket actually attack to this drone, to this UAV, we are going to lose our mission. So what would happen here? This drone has a UAV, since it's a composition of the 5 smaller drones, has a higher wingspan. It can fly in the higher elevations, and in three conditions, it can separate it. So if it be in the danger of attacking by rockets, or in the second one, once you want to cover a huge area, so once this drone is converted into 5 smaller drones, they can actually cover huge areas because you have 5 set of camera sensors, so you can cover more because you have more drones. In the third situation, once you want to increase your stealth property, it means that you don't want to, for example, the radar capture your drones. So here you want to reduce the size, you want to get the speed, and you want to go to lower elevation so you can have a smaller drone. So this is one of the concepts that we have looked. So we talked about the V formation. We said that usually the drones which are in the mid position, in the leader position or tail positions, they are consuming more energy compared to the drones which they are at the middle positions. So what would happen here if we look at the nature? We saw the bees and the flowers that they work together and both are taking advantage. So once these drones flying together, if you look at these drones which are in the middle, they have saved more energy. So it means that they have more level of the energy in their batteries, or they can fly more because they have tolerated less drag, because they have been in less consumption positions in the formation flight. So what would happen if we assume that the birds, the drones, which they have the less level of energy, so if we don't protect them, they will fail and they are going to lose our formation flight. What would happen if these smaller drones, the drones which they have the small level of the power or energy, they attach to the drones which they have the higher level of energy. So what would happen here, if you look at here, this is actually like the bees and the flowers, because they both can take advantage. How? So once the lower power energy drone is attaching to a high energy level drone, like here, these are attached together. Imagine that the blue color drone is a low level and the white color is a high level energy. So once they're attached together, you can preserve the low energy level drone, so it's not going to crash. And also, once you're attaching, you're increasing the wingspan, you're increasing the size of the aircraft, which this is good because the drone eventually consumes less energy. So they both can take advantage, the white one, the blue one. So this is actually exactly the same thing that we are looking at in nature, which is called mutualism. So the mutualism is one of the phenomena from the nature that we are looking at, that to design some drones which can fly actually together for different types of missions. So let's change the topic, and I'm going to show you some interesting research that I have done during my PhD, and also the novel research that I have initiated. I'm still working on that for different species of animals. So always we are looking at the nature to see that how we can get benefits from the nature, how we can get inspiration from the nature, because we see that through the millions of years, any species I mean, through the evolution become as the optimized shapes, optimized behavior, materials, objectives, and etc. So one of the interesting topic that I have looked at that is that once we look at the birds, let's just consider the birds. So we know that the birds, they have different colors, right? So what is the explanation for different colors? So for example, what biologists they're explaining, because this is more biology. So I mean, we are engineers, right? We don't know what's going on in biology, but somehow this interdisciplinary or multidisciplinary research will help us to understand or explain something that maybe biologists they cannot do that, or we can understand something that biologists they know and we don't know about that. So what we can find from here is that if you look at the sources of the bird's wings color, so what is the main reason that the birds have different colors? So for example, the black color or the white color or the other color. So what, from the biology perspective, the colors come from the pigments, right? So the main explanation from the biological perspective to the colors of the feathers of the wings of the birds is that we want to save, we want to they want to escape from predator through the camouflage, or for example, the bottom side is white because they don't want to seen from from the ground by other birds, or for example, the top is the top color is the white, or for example, some of these species they have for example they want to attract the mate, so it's for genitomorphic points of view, but actually we haven't looked at aerodynamic aspects, and from the because these are flying objects, so we can, as an engineer, aerospace engineer, we can look at these birds and explain why they are selecting these colors. So what we can explain here, let's start here with the migratory birds. So if you look at the oceanic birds like albatrosses, sooty tern, shearwater, or the black skimmer, they have black and a white color. So I'm going to show you here one of these birds. So this is an albatrosses that they have black color at the top and they have white color at the bottom side. So why they have this different color? So we know that black color on the feathers of the migratory birds or other birds is coming from the concentration of a material which is called melanin. So this melanin depends on which part of the wing you have this more melanin, you have more dark or black color. So since we are living at New Mexico, if we go outside during the summer with a black t-shirt like what I have right now, so the black color is absorbing more heat. So what would happen here, we will feel more hot if we have a black t-shirt and go outside and we expose ourselves to the sun radiation. And if you have white t-shirt, so we'll feel more cool, right? So actually what would happen in the nature, these birds, these migratory birds, albatrosses, as you can see in this image, the top side of the wing is black and the bottom side is white. So what would happen here, the black color is absorbing heat. So it means that the top surface of the wing is heated more. So what would happen here? So since the temperature is increasing, since these are a flying object, they are moving in the air, so the top air, which is at the top of the wing, it will be heated. So it has a higher temperature. So we know the density of the air is reducing with increasing the temperature. And the bottom side is cooler, so you have the more dense air there. So what would happen here, because of this temperature difference that I'm showing next slide, which is almost 10 up to 25 degrees centigrade between the white color and the black color. So this heat wing, it actually helps the birds to save energy because they have a drag reduction, because they are flying in the top side, which is exposed to sun radiation. As you can see here, they are receiving the solar radiation and atmospheric radiation, which would increase the temperature at the top surface of the feeders. And I mean, once this happens, this increasing the surface temperature would increase the lift because the top surface is hotter than the lower surface, and this would act as a hotter balloon, so they get lift, so they can get fly upward. And at the same time, they have a drag reduction. This is the main reason, our explanation as an engineer, what these migratory birds, like albatrosses, they have a black color at the top and they have white color bottom side. So we have done some simulation with the software, which is I'm going to teach you to see that actually how this temperature difference would help these drones to fly further and faster. So the main reason here to look at this study, we want to design some drone that can fly further and faster. So this is called bioinspiration, biomimetics, that I'm going to explain these terminologies between bioinspiration, biomimetics, and what is the difference maybe in the next slides. So if you look at the aquatic animals, they have the same pattern, like killer whales, dusky dolphin, they have black and white. So the same concept is happening here on penguins, on the sharks, swordfish, sailfish, dusky dolphin, killer whales, they have black and white. So next slide, I'll show you some video and I'll explain this one with more details. So what inspiration we can get from these colors? So imagine that, I mean, in aerospace industry, we are flying an aircraft. And this aircraft is flying for a long time. So it means that the aircraft can, I mean, we want to reduce the drag, right? So every second we have flight in the world. So imagine this color effect can create a small change in the drag force. Drag is the force which resists to our object to fly in the air, right? It's the resistance force. It's not good. So we want to always reduce the drag. So what we can do here and what inspiration we can get from here is that imagine that we have 0.00005% drag reduction in the passenger aircraft. How many flights do you have per second, per minute, per hour, per day, per year? How much fuel it can be saved here, right? Because once you have less drag, it means that we are consuming less energy. We can save more fuel. It means, I mean, it's more economic. So maybe it's not a good idea to just paint the top part of the wing of the aircraft black, because maybe it has some psycho effects or something. This is the main reason I have written literature in the news that why all the airplanes are white color. But let's look at the other species of the migratory birds. So the albatrosses that we saw here, these birds, they are oceanic birds. It means that they're flying over the oceans, over the waters. But these birds, which they are the land birds, like pelicans, like eagles, like, for example, conure. So these are cormorants. These are other birds that are flying over the ranks, or northern bald ibises. So if you look at these birds, we always see the tip part of the birds. This is called wing tips. These are black color. Why? Right? It's always white. So if you look at again from the biology perspective, we will see that this black color is happening again because of the concentration of the melanin. And why we have the concentration of the melanin at the wing tips of the birds? Because here it means that this concentration of melanin in the wing tips, it means that the birds, they want to increase the strength of the feathers in the wingtips. But we as engineers, again, we have other explanation. We know that at the tip of the wings, which are here, usually we have vortices. There are some vortex-shaped flow. That these vortices, they are increasing the lift. They are increasing the drag, and they are not good. But we found that black color has a higher temperature than a white color. And the black color is increasing the temperature of the wingtips. So it means that it reduces the drag, so it reduces it. So this is the main reason that this, I mean, that we are thinking that these birds possibly they are selecting black color at the wingtips. And then we can get inspiration for the winglet of the airplane. So this is a blue color, as you can see. And here we wanna actually colorize the passenger aircraft black color to see that how they can advantage from this color effects. So in this slide, actually always we need to run some experiments to prove our hypothesis or our theories, or actually to verify our modeling or simulation. So this is actually experiments is the good things that we can verify, I mean, the results that we are getting through the analytical solutions. So what we did, I mean, in the summer 2019, in my research laboratory, we got two birds' wings, one with the black color and another with the white. We exposed them in the heat lamp that we mimic and actually simulated the sun radiation. And here with the thermal camera, we took the pictures from these wings. And we saw that one of the wings has black color, the another one is a white color. And here we see that the black color has a higher temperature than the white color, and we found that maximum of 25 degrees centigrade, since the temperature would be saturated, is a difference between the black and the white. So then what we did here, we made the wings with different airfoils. So airfoil is a cross section of the wing, that which is I'm going to talk a lot about this concept during this course. And we use the heat films at the top of the wing, and we increase the temperature. And we found out how much this temperature difference would help them in the lift and the drag in the wind tunnels. So let's look at what would happen in the nature and actually on the albatrosses. So albatrosses is one of the largest birds. They have a wingspan of the 3.6 meter wingspan. They usually fly for a month once they're migrating. They harvest energy from the shear winds over the ocean. And also they don't flap, so they're just changing their banking angle. This is called banking angle, as you can see here, and they are harvesting the winds over the ocean, which is called this behavior dynamic soaring. So since they are not flapping, the top part, which is a black, is exposed to radiation, and the bottom side, which is a white color, is exposed to the heat flux from the ocean during the night. And these birds are just sleeping for 2 seconds during the night during migration. One of the longest migratory birds, so they can fly for 9,000 miles or kilometers during their migration for non-stop flight. And the main reason is that they are harvesting energy from the shear wind over the oceans, and also in the same time from the sun radiation, because of these color effects that they have. So as I said, the same approach they can be seen in the killer whales. If you look at the killer whales or dusky dolphin, they will show this type of behaviors. We know the killer whales, they are predators. So there are no larger species or aquatic animals than the killer whales. But why they have black color at the top, right? I mean, what is the main reason? They have black at the top and white at the bottom side. We explain this actually with this color effect. So this is the behavior that you can see. The black side is outside of the water, is receiving sun radiation. It can be heated. They have a drag reduction once they are actually moving under the water. So before explaining about this airplane, I want to talk about these butterflies. So since you're talking about the colors, right? So it's interesting to know in any species that you are looking at, we can maybe explain some engineering explanation that why they are picking this color for themselves. So let's look at the monarch butterflies. So the monarch butterflies, they are some species that they are actually migratory butterflies. So we can see them in the United States. They are migrating from Canada to the Mexico. And in literature, the biologists, they have seen that the butterflies, which they have the darker color or reddish color, they can fly further than the other butterflies. So we as engineers, we need to have explanation for that. So since we had this experience with the birds, we can exactly say here, black color is absorbing more heat, so they will fly in the lower dense air. So in this case, they can have a drag reduction. So this is our explanation why these butterflies, they can fly longer distances. So these are some actual studies that we did, and we see that these traces of the black colors shows a higher temperature than the rest of the wings. So I am talking about this picture. So what application and what idea we can get from these colors, how we can implement this to the nature. So let's say that if you have an aircraft like this, if you apply some heat films that they have a 0.5 millimeter thickness at the top of the wings. So what would happen if you increase the temperature of the top side? It's something similar that happened in albatrosses. So increasing the top surface temperature, it would enhance the flight efficiency. So it means you have a drag reduction, you can enhance in the lift. So your airplane can goes up. So what would happen if you increase the bottom side temperature? So in the bottom side, actually if you have a heater, so your drone, your aircraft goes down. What would happen if you increase the temperature of the one side of the wing? So increasing the temperature of one side, it will help these aircraft to have a roll control. It means one side you have more lift, the other side you have less lift, so it creates a moment, so you can have a roll control. So these are some materials, terminology about roll PTO, 3 different axes for the equilibrium or the stability of the aircraft, which I'll talk, in future lectures. But in shortly, what I want to say is that this temperature control actually we can get benefits from that, and somehow we can control the airplane with just changing the temperature. And this is one of the interesting projects I'm looking forward to do that more to the experiments. So as I said, drones have different types of applications. So one of the applications of the drones is for marine environments. Marine environments means that we can have different types of drones which can fly on ocean or on the seas, or for example, in marine environments. So in marine environments, sometimes we don't have a station for our drones. So if you have a larger drones, the larger aircrafts, we need to have actually a runway for them, right? So this is the reason that the ships are used, or they should be launched. So looking at the nature again, it can give us some inspiration to design some aircrafts or some drones that they can fly like those type of species and can perform different types of missions in the oceanic environment. So this mission can be, for example, for monitoring the oil spills. It can be for monitoring some species of the animals under the water. It can be for, different types of studies, can be for military application. There are a bunch of applications that drones they can have in marine environment. So let's see this video and see what would happen in nature. So if you look at here, we will see that what would happen here, these birds, they dive into the water. So it means that, and they can swim under the water. Or for example, let's see this, the next video, which is about flying fish or flapping fish and the manta rays, which they can flap. There are some species, aquatic species, that they can come out from the water, they can fly over the water, and they can flap. Or we can see the manta rays actually doing the same behavior. They can fly for short distances, but they still can come out from the water and they can fly like flapping wings, like birds. So what inspiration we can get from this idea. So if you look at this picture, we will see that we can design a drone which they are a flapping wing, like the birds. They can flap, they can dive into the four their wings, they can dive into the water, change the configuration to fish, and swim under the water. So this is one of the projects that actually I have looked at that. And this is also another concept that we are looking at, that is, these are the drones which can fly over the ocean, and they can harvest energy from the shear wind over the water, like the albatrosses changing the banking angle, to the dynamic soaring, harvest energy from the shear wind over the water. Or for example, they can land over the water. We know always over the water we have the water waves, and so once you're landed over the water waves, as we can see here, some waves here, they can harvest energy from this type of motion, and also we can integrate solar panels at the top of the wings. So this concept is actually designing a drone which is an amphibious drone, because these drones can fly over the water, can land over the water, and perform different types of missions. So this drone is flying as a drone, as a UAV. It has an underwater robot, as you can see here with the yellow color underneath, can fly over the water. It can release this underwater robot into the water, and somehow they can work or communicate with each other for wildlife monitoring under the water, or for different types of applications. So here we're also looking at designing some stations that we can have drones. They can have solar panels and some radars in order to communicate with the ground stations and implement them in the oceans to monitor the oceanic environment. So this is called amphibious drones. Or other concept which is so interesting, and always looking at natures, gives us some idea, is about this species. So if you look at the nature, we always get very, very interesting ideas. So this is a type of the lizard which can run over the water, and they don't dive into the water. They just can run over the surface of the water. We saw the spider which was rolling. We have the jellyfish, and we have the octopus that they show some behavior. So now think about designing a concept like this: is a spider inspire rolling rover which can roll over the water like this spider or this lizard, and also they can fold its legs like jellyfish and octopus, and they can sink into the water, swim under the water, and perform different types of missions. These are other projects that actually one of my master's students, she's working in this topic. So, since this is the overall lecture, I want to show you how nature can help us to design some systems for implementation of the drones for different applications. So if you look at the nature, we always see the nest of the birds, right? So where the birds live. So usually the birds, they are living in their nest, right? So they are living in their nest. So if you remember, we said drones have 200 applications, but we are not using drones in our daily life. So what we can do here. So let's look at from this perspective. So drones, they are actually have plenty of applications, but we are not using them. They can be just used for a hobby. We can get a quadcopter from Walmart, just like as a hobby, or some photography, taking pictures, or for example, for military applications. The main reasons, the application have been limited by, different reasons. But this concept that we are looking at, and we have called it as the nest, is network efficient strategy, which is exactly like the nest of the birds. So what we are thinking about that, if you want to apply drones in the cities, right, which is called a smart city, we want to make our city smart. So what are the opportunities that we can deploy the drones for different types of application? So imagine that we want to apply drones for A police car is chasing a car in the downtown of the city, stuck in traffic. They can deploy and send a drones for chasing that car. Someone has a heart attack in the street, and you want to send the ambulance drone. You want to do the pollution monitoring. You want to do the bridge inspection. You want to do the firefighting drones. You want to do clean the solar panel at the roof of your house. You want to do for airport inspections. You want to do for cargo delivery. We know that, I mean, drones have plenty of applications. So one of the applications for pizza delivery. I know that Domino Pizza in UK, actually they were using drones for delivery pizza. Or for plenty of applications, as I mentioned, there are 200 applications for implementing drones in the city to have a smart city. So looking at the nest of the birds, we can see that if we have some branches like this, and if we integrate these branches to some available actually stands. So these stands, they are lighting poles. So the lighting poles is the best stands to integrate these structures to them in order to actually as a housing of our drone. So drones can land there, they can protect it by some shell, we can have a solar panel to charge them, we can charge them by RF or radio frequency energy harvester, like the Wi-Fi charging that, I mean, we can see for some of the phone they can charge wirelessly. We can use the same concept for drones, or for replacing battery. I mean, we can design these stations in such a way that we can replace the battery. So we can have this station, we can make an app for our phone, and somehow we can insert your name, we can insert our last name, find our location. For example, you want to clean the solar panels of your house, then we can send the instruction and send, select the type of application of the drones, send your location, drones would fly and actually would perform the mission, and then where they should go back. So if we see that, if you have 500 drones, 500 applications, and 500, let's say, stations. So how we are going to manage these big robots or a large number of the drones for smart cities application. So there are different types of algorithms that I'm going to show it to you here, but I mean, this is just for information. So we found that if you use different, more optimized way, that drones, they have different level of energy, they have different distances from the station or mission, and drones, they have different, and their charging station, they have different level of power. So if each drone get back to its pre-assigned station, this is not optimized way, because we cannot have more agile system. So this way, it's more optimistic or better or optimum if the drones, actually we can minimize the whole energy required for the drones to perform different types of mission. So this is some simulation that we have done, which is out of the scope of this course. So there are other good things that we can look from the nature, and I'll give you for each one of these aspects more detailed lectures, is the applications of the drones for military. There are plenty of the ways that we can actually hide our drones, or we can protect our drones to be recognized, or to be tracked, or targeted, or to be attacked. So if you look at the nature, there are different ways that animals, they are applying in order to escape from the predator. So for example, how small birds can escape from a predator bird. Or for example, how a lizard is sacrificing the tail to rescue the rest of its body, or how a lizard is changing its color, right, for the camouflage. Or for example, how a frog is playing dead. Inspiration from this phenomena, we are looking at some concept or some optimized systems that can be applied in the drones in order to save them from predator. So I call this one inspiration from anti-predator adaptation mechanisms of animals to design anti-predator drones. So for example, we can design a drone which can sacrifice some parts to the rescue the rest of its body. Or some drones, they can camouflage, they can change the color. Or some drones, they can apparent fall, to show that they are dead. Or for example, designing some algorithms or some programming on the drones that can escape from any predator rockets. So this is something like prey and predator. And this is one of my last slide that I would like to show you is one of the other applications of the drones for underground mines. I will give you also a presentation about this and how drones can be applied in underground mines. So if you look at the underground mines, there is the GPS doesn't work there. There is no light there. It's so harsh and moving actually environment. It has very harsh conditions. We are not allowed to use the LiPo batteries because maybe in the coal mines there are the possibility of the explosion. So this is the reason that we want to apply the drones and how we can implement the drones in the underground mines. So what you're thinking here, we want to preserve and protect our drones to, for example, attach the walls or the cars which are moving, the trucks moving in the mines because of this harsh condition. So we are looking at designing a cage with different shapes, which is aerodynamic. It is not going to blocking the sensors, and it has enough, stability or strength in order to actually to be faced to different dangers that we may have in underground environment. So this is one of the concepts, a spherical drone that we have designed, and in one of the lecture I will give you more explanation about this, that how this can be applied for this drone which can fly actually in an underground mine condition, and it can use LiDAR or different types of sensor to navigate in the dark condition underground mines. So this is one of the first flight tests, and this work is with the collaboration of the mining engineering department and also a bunch of undergrad students that they have made these drones in the mechanical engineering department. So I'm going to show you a first flight test of this. So thank you so much for your attention. This was our first lecture that I wanted to show you how nature can help us for drones, or what projects that we are doing at New Mexico Tech. In the next lecture, I am going to start actually to talk a little bit about the aircrafts and about drones, about the actual application of the drones, some overall views of the projects that we are doing at New Mexico Tech, and also start to go step by step for designing a fixed wing drones that we can learn how to design it, how to simulate it, and how we can actually make it. So I hope that you have enjoyed this course, and in the future lectures, I'll go slower. So somehow, you you have different, majors, and I'll try to accommodate this course in such a way that everybody can understand this material. And in case if you had any question, feel free to reach me through my email, and I am looking forward for the future lectures to receiving your feedback or email for the lectures that I have here for this presentation. Thank you so much, and take care and have a nice day.